Hi, and welcome to the webinar. LENSEC sponsors these webinars monthly, and we cover a variety of safety and physical security information, so check back with us to find out what's coming up next. Today, we will be discussing securing your facilities using technology. And my name is David Martin. I'll be your moderator today. Before we get started, I'll give you a brief introduction to LENSEC. Since 1998, LENSEC has been a trusted security and surveillance partner with experience in the U.S. and around the world. LENSEC has a background working with many types of industries, and we help customers develop enterprise solutions for complex physical security projects. We've developed a powerful security platform called Perspective Video Management Software. This is an enterprise CMS that streams and captures IT security video and incorporates video analytics, access control, RFID, and more into the software. Before we get started, I'll introduce your speaker in just a moment, but first let's go over a few logistics for the webinar. We'll be taking questions during the webinar, so if you'll see in the bottom of your GoToWebinar panel, you can enter your questions there. We'll collect those during the presentation and then have a Q&A at the end of the event to answer as many questions as possible. During the webinar, we will present poll questions and encourage you to participate in answering these questions when they are presented. And then at the end of the webinar, we'll present a survey for attendees. We'll ask that you answer a few quick questions to help us better serve you in future webinar events. And if you're interested in a completion certificate for today's webinar, indicate that on your survey, and then we'll follow up in a few days after the webinar with certificates, answers to questions, and a copy of today's presentation. Also, we record these webinars, post them on our website, and we'll provide you that link to the webinar video archive so you can review this particular webinar or previous webinars as well. So today's physical security expert is Keith Harris. He is the marketing director for LENSEC. Keith his skill working with law enforcement and government customers selling the video security products. This includes training law enforcement personnel on video surveillance and investigation techniques. Keith spent over 20 years in the broadcast news industry as a video journalist and newsroom assignment manager as well. He has several years experience working in the video security industry. So Keith, if you're on, thanks for joining us, and we'll let you go ahead and start your presentation.
Thanks, David. I appreciate it. Today we are discussing securing your facilities using technologies. We'll cover security technology, integration, tech advances, and training, as well as maintenance and service. We've got a lot of ground to cover today, so buckle up and we'll get started. Facilities come in all shapes and sizes. You could be talking about an office building with multiple floors, or it could be an industrial complex, campus environments like a hospital or university with many buildings. Facilities do have some common core elements that are important to consider when we're looking at this physical security environment. Inside the building has different needs than outside the building. The main areas where people access a building are key. Traffic funnels through the areas, and through entrances and exits. And it's a great spot to capture information about who's coming and going. Lobby areas can vary greatly depending on the building layout. They may be bright and wide open, or some may be very closed in and tight. Hallways and offices are also key areas that we want to monitor. We want to make sure we're taking a look at interiors areas as well to help track activity. Outside the building, it's also important to take a look at the security footprint. You have assets out there that need to be secured. It could be employees' vehicles, company fleet, or equipment. The outdoor areas like parking lots have different needs than interior areas. Your environment's different, so different equipment is going to be required. All the traffic entering your building has to come through these areas. Your perimeter may or may not be fenced. Keeping an eye on your perimeter is dependent upon your overall security plan. You could ID problems at the perimeter that can alert you before the problem moves inside the building. And the warehouse environment can be a weird combination of interior and exterior needs. You have a lot of products stored out there. It's a profit center for you, and it's susceptible to attack from internal and external sources. You want to consider using loss prevention methods in the warehouse. Also, safety can kind of come into play. With employees working around heavy equipment and moving boxes, keeping an eye on safety practices will be helpful. Let's take a look at the layers of security around a facility. We're going to take a look at this public building. Of course, I'm here in Texas, and so we're going to take a look at the state capital of Texas in Austin, my hometown. When you consider the Capitol building, we consider the building itself to be the highest target. So we're going to designate that as the secure zone. Here you'll have the tightest security. Security guards are going to perform ID checks for visitors, require employee badges. You may even have a required bag check and metal detectors at high-profile areas. Security may require canine and foot patrol to keep constant visual surveillance on your target areas. In this zone, you may need heavy camera surveillance. Due to secured nature of the area, live monitoring of the cameras also makes sense. You'll also find access control for secure assets. Now, your next zone is the patrol zone outside of the building. This zone, security guards may be on scheduled foot or vehicle patrol. All employees and security will be advised to be aware of their surroundings and on the lookout for trouble. The old adage, if you see something suspicious, say something, comes into play here. In the patrol zone, medium surveillance will be used. Camera coverage may be in use, but it may not be as prevalent as in the secure zone. You have a much wider area to cover here. As we work our way outward, away from the secure area, we find the observation zone. Security will be more sporadic as a lighter level of patrolling will be required. Employees and security are aware of what's going on, but they're not as intense in their observation in the observed zone. Surveillance will be lighter here. Cameras watch access points to the property. And then on the very outside edge, we have the unsecure zone. This area is not patrolled. Employees and security are aware of the surrounding area, and you'll find little to no surveillance, but it's still part of the overall security footprint.
Okay, that brings us to our first poll question, which I'm going to present here. And as this comes up, you'll just want to select your best answer. Okay, so the first question would be, what is a choke point? And you've got a meeting location, employees should gather in evacuation, access point where traffic flows to enter or exit a facility, where a security guard applies pressure to gain control, or could be all of the above. So we'll give you a few minutes here to go ahead and place your answers.
David, I first heard this term from our good friend Jake. He's the one who taught me about choke points.
And I'm going to go ahead and close this, and then I'll let you speak to that.
Sure. Taking a look at choke points is important to understanding your access points and do you have the results there, David?
Yes, they should be displayed. They should be displayed.
Yeah.
What's that, Keith?
Could you read those out for us?
Yeah. So 100% selected was access point where traffic flows to enter or exit a facility.
We've got a smart crowd. That's good. That's exactly right. When you take a look at your choke points, you're taking a look at access points where traffic must flow to enter or exit a campus or facility. When you're looking at a parking lot, the obvious choke points are the driveways. These are most likely spots for vehicles and likely foot traffic to access your facility. You could easily consider entrances to the building to be a choke point as well. Cameras are important to train on these choke points to help you capture valuable info about vehicles, people entering your facility. And you'll want to narrow your field of view from your cameras and provide higher resolution images on these areas to help capture detailed information about people flowing through your property. You may want to capture license plate detail in optimal circumstances. You may be able to capture detail about the driver or pedestrian that enables you to accurately identify the person after the fact. You'll also be able to capture info about vehicles such as make, model, color, and distinguishing characteristics. Parking lots that need controlled access will have security gates. It's a great spot to capture the detail you need with cameras. And you know why? Because the vehicle stopped. Conditions are ideal for capturing that information. When it comes to security technology, we sometimes hear about enterprise-level security deployments. Simply put, an enterprise system has more than a few sites and servers. This is called multi-site deployment. An example would be a company with remote branches around a region across the country. Advanced software ties these remote locations together, and not just for video and access control data, but also for easier administration. An enterprise software will allow you to set up users and groups in a simplified access directory integration. The software is mapped to Active Directory. When changes are made in Active Directory, the information gets pushed out to the enterprise software. Admins can easily replicate changes to devices from remote locations. And the Active Directory integration in the software greatly simplifies user logins and permissions, including single user login where required. The IT department may need to administer configuration for software from a central location rather than on site. Central management of that software will simplify that for administrators. Enterprise systems should include redundancy in the system for network servers. Central management makes that job much easier for the administrators. In the enterprise environment, a user can have easy access to their permissions from any remote site. The administrator should be able to make configuration changes without being on site at the server location. And finally, enterprise software provides utilities for system reporting and health monitoring. When we apply this to enterprise video management software, users can access all live and recorded video stored at a central location. The enterprise VMS provides central account management of the software across multiple servers. The need to update passwords manually across remote servers is eliminated. Batch updates for configuration of multiple cameras is made much easier, and management of hundreds and possibly even thousands of cameras is included. It's very important to consider a VMS manufacturer who's willing to work with many different IP camera models. They may only want to support their camera brand and not cameras you're interested in using, or cameras you've already installed. But you want to make sure that you open that up and have an ability to use additional cameras should you be required to. Also, other integrated systems such as access control and video analytics will need to be supported by the enterprise VMS. Sometimes enterprise VMSs are complicated, and when it comes to making changes in the software interface, it can get confusing. Check and make sure your configuration will be easily learned and applied by system administrators. You want to make sure the features that you require are included. VMS software is usually accessed in two ways, either via a thin client or via a thick client. A thin client is a software user interface that accesses VMS features without taking up too much space on the client workstation, such as a browser-based user interface. A thick client needs to be installed on the user workstation and may require updates that need to be administered locally. I recommend a thin client if it's full-featured. It'll be greatly beneficial and save your IT staff from visiting each machine initially and with system updates down the road. A VMS worth considering will have an easy and powerful user interface. This will make the end user's learning curve very easy without stripping away any important features. A health monitoring service generates a health report related to cameras, servers, and other components. The service notifies admins about the offline status of cameras or server problems. Many users need to watch video remotely from their home or while on the road. This may be a user monitoring one site and logging in to view activity from across town, or it may be a user monitoring many sites spread across a region or across the country. A monitoring company may be employed also to monitor your system away from the facility. A VMS that provides integrated alarm management inside the software will be useful. You'll also want to take a look for an ability to prioritize alerts and forward those alerts to other users and report on alarm management features. Even a workflow tool can help automate notifications and activity within the enterprise software. Camera mapping features can be very important, yet some VMSs don't provide a mapping capability. Camera mapping is useful for users who are not familiar with camera placement. It could be a first responder who doesn't log into the system regularly, or it could be a remote user who isn't on site often. This improves situational awareness when you have a building layout with camera placements and you're able to see a live camera view of that area. An enterprise VMS with a user collaboration tool provides certain features for interaction among users, such as the ability to share current live view or archived video view among users. This could be a great way to get useful info, tag video, even multiple camera views to others investigating an event. Sharing notes and events within the system keeps the metadata connected to the video event for future reference. Now we're ready for our second poll question.
Okay, I'll get that prepared for us. The question is, advances in image processing in recent years have improved which of the following? And your selections for advances in image processing in recent years have improved which of the following are camera size, advanced features improving image quality and resolution, cost of equipment, non-standard viewing aspect ratios, or all of the above. And again, we'll give you a few minutes to make your selection.
It's really amazing how they've changed up some of the image processing over the years. When I started this, image processors were very basic. They didn't have much capabilities, and that wasn't that long ago.
Yeah, and it's still ever changing with the advancements in different lighting situations for different environments. So let's go ahead and look at the results. Okay, and I'll read these out for you. So 100% chose all of the above, Keith.
Well, again, we have a smart crowd because that's exactly right. All of the above is correct. So let's take a look at IP cameras here. Most commonly, camera deployment locations are entrances, hallways, and offices. One camera may not likely cover all locations equally. At entrances, you should use a wide dynamic range camera for contrasting scenes. Medium or standard resolution is typical, though in a large open lobby like the one pictured on your screen, cameras with higher resolution may be required for capturing good images. Hallways may not need high resolution on hallways. A medium resolution camera may work. Capturing general activity may be adequate there. In offices, having cameras for the offices where essential materials are handled is very important. This could be process areas where safety monitoring is needed, or clerk stations where money passes hands. Placing a camera with a wide-angle lens in one corner can provide coverage for an entire room. For an average-sized conference room, say 20 by 30, a 1080p camera will offer much better detail than a 720p camera. For parking lots, higher megapixel cameras can really improve your ability to cover a wide area and still capture detail. However, outdoor scenes at night could be affected if your megapixel cameras are not equipped with low light capabilities or infrared illumination. Camera position is key to help reduce glare from light sources in the field of view, such as parking lot or street lights. Striking a balance between a wide field of view and recognition of subjects must be carefully considered. Coverage of those choke points we talked about will help with recognition of subjects and capture license plate detail when needed. It's helpful to consider existing lighting conditions in the parking lot. If your lighting is subpar, cameras may be unable to capture useful video. Supplementary lighting plans may be needed to help your overall security plan and improve your ability to capture detail in your video. If you're in a high security area due to a high crime rate, having cameras and access control at your perimeter may be essential. If you know of specific trouble spots, evaluate your need for cameras to capture activity. Cameras with longer range lenses may be needed to focus on trouble spots or high priority areas. And then let's talk again about the warehouse, that weird hybrid combination. It's hybrid because you have large open areas that create the need for long-range cameras, such as what you might need outside. During the day, interior light may be good, although you may have lighting with sodium vapor lights that can affect your image quality. At night, the warehouse could be quite dark, so infrared lighting may be needed to cover target areas or cameras with a low light capability. I'd recommend using a high-definition, wide dynamic range camera at your dock doors to monitor activity and track assets. And we'll go over wide dynamic range a little bit more in the coming slides. You want to make sure you add cameras outside the dock area as well. This can help you monitor trucks and forklifts maneuvering around the dock area. There have been significant advances, as we discussed, in image sensors in recent years, leading to better technology, smaller camera sizes, and lower prices for equipment. The camera's automatic exposure tries to get the brightest image to appear as the human eye would see a scene, but the camera can be easily fooled. Strong backlight can cause objects in the foreground to go dark. So cameras with backlight compensation will ignore limited areas of high illumination, just as if they were not present. This feature enables objects in the foreground to be seen, although the bright area may be overexposed. In advanced network cameras, a user is able to use exposure zones to select areas of the scene, center, left, right, top, or bottom, and that should help the scene be more correctly exposed. Wide dynamic range is a camera sensor feature to handle a wide range of lighting conditions in a scene. See the example on your screen there at the bottom right. In a scene with a lot of contrast where a person is in front of a bright background, an image is produced with dark target areas that are hardly visible. Wide dynamic range solves this by using different exposures for different objects in a scene. And this will enable objects in both bright and dark areas to be visible in a perfect exposure. Image noise is the interference of a video signal that will show up as grainy specks in the video. This can be caused by low lighting conditions, nearby power interference, heat, etc. Your example there is on your screen in the top right. Digital noise reduction is a technique of removing image noise from the video signal by applying a digital comb filter. It makes the image clearer and reduces the file size. Determining whether you need standard resolution or high resolution usually requires considering several different criteria. Keep in mind that using a high-def resolution is not always better. You have to strike a balance between resolution, image quality, bandwidth availability, and storage availability. Some high-priority areas will absolutely require megapixel video. If you're covering a large area with one camera and need facial recognition, the megapixel video is a must. However, a low-priority area with little coverage may only need a standard resolution camera. Pixels per foot, or PPF, is a metric that delivers a specific level of quality. For example, using this metric should enable the selection of the right resolution for the scene. In the image following the PPF metric should deliver a predictable level of quality. Calculating your PPF depends on two factors: the number of horizontal pixels in the video and the width of the field of view of the camera at the point of interest. Be careful to properly identify the horizontal pixel count. Don't confuse it with the vertical pixel count or the overall resolution. For instance, a 720p camera has a total resolution of 1 megapixel, but its horizontal pixel count is 1280 and its vertical pixel count is 720, more commonly described as 1280 by 720. It's the first number in this pair, 1280, that counts for measuring the pixels per foot. Second part of the picture of the calculation here is how wide the field of view one wants to cover. Determining pixels per foot in relation to the level of detail desired can be determined by following this chart that's displayed. Quality of the detail desired is indicated in feet of horizontal coverage, and the quality levels are broken down in 3 levels. General details are able to recognize general movement and activity. There's no fine detail that can be determined at this level. You may not be able to make out facial features, vehicle details, etc. Forensic details take you up a notch. You can start to make out facial features, the make and model of a car, etc. And a high level of detail provides the best detail and clarity available in the scene. You can make out specific features in a face. You can maybe clearly identify the driver of a car. You may even be able to make out the denomination of money changing hands. Setting the proper camera view can be helpful in getting the right video evidence recorded. A few unique camera setups should be considered. Look at the hallway video area can be wasted on blank wall space. Using a camera with quarter mode can provide a unique space ratio, capturing more of the key video area. However, using quarter mode could result in loss of pixels per foot, reducing recognition and clarity. Quarter format allows cameras to maximize video surveillance in narrow vertical situations. This format creates a unique high-quality vertical video. Traditional HD video is recorded in a horizontal or landscape format of 16 by 9. That's wider than it is tall. The new quarter format in some cameras creates a vertical portrait video that's now 9 by 16 in aspect ratio. That works better in tall, narrow spaces. This helps avoid recording unnecessary space where useful activity rarely occurs. And you want to make sure your VMS will support that feature. In certain situations where higher resolution is needed in a panoramic arrangement, multiple cameras may be deployed, as you see at the bottom of your screen. Each single camera view is a camera capturing a narrow field of view. When the software arranges these views side by side, activity can be tracked across a wide area. The advantage of this arrangement is a higher resolution on each individual view. When we're taking a look at a panoramic camera, it's set up a little bit differently. It achieves a coverage of a wide area. When we're looking at 360 and quad camera views, the first one we take a look at is an axis camera configured to cover an area with a 360-degree view. It can show the view as displayed in one camera viewer window, like the view we see on the upper left. Or it can be broken up and de-warped to show 4 separate views in a quad view format for one camera, like the view on the right. The second example at the bottom of the screen is a high-resolution 180-degree view. Like the multi-camera setup we saw previously, this is a wide-angle view in a panoramic format. However, the difference is the view displayed here is using one camera. The user can digitally zoom in on a high-resolution image to capture activity across the panoramic view. It is important to note that any wide-angle camera can reduce clarity for target areas that are not in close proximity to the camera, though this is impacted less in a megapixel camera image. Capturing audio should be considered in certain circumstances. You may want to capture audio where the public interacts with your employees, or it could be where cash transactions occur. Police even use audio in their police interview rooms. And clear audio is the goal here. Many times, mics built into cameras are subpar. They don't capture usable audio. An external mic can help solve this. LaRue, for example, makes a great microphone that filters out unnecessary noise. They provide an amp that can help you adjust the volume transmitted to your recording device. Poor audio is often due to poor placement of the microphone. The camera position may be great for covering your field of view, but it's not a good position to hear the audio required. You want to consider placing that mic close to where people interact. Avoid placing the mic near air vents. You may accidentally pick up wind noise that can mask the audio that you're trying to capture. The audio may not need a home run back to the recorder. If you're associating the mic with an IP camera, you can use the audio inputs on the mic and transmit your audio back via the network. Audio-video sync is very important, especially in archive playback and downloaded video clips. Make sure your system addresses this. Some do not, and you want to make sure you're checking that out if you're adding audio for a project. Audio analytics is an emerging technology. LaRue now has what they're calling an aggression detector software. 90% of physical aggression is preceded by verbal aggression. That integrates the The aggression detector software integrates into a video surveillance system and could alert personnel at the precise moment specific acoustic events happen. What that software does is it analyzes the incoming audio, detects rising human aggression, anger, or fear, and then an alert can be generated and triggered to warn staff immediately. They can take steps to prevent physical aggression before it occurs. Again, this is a new technology, and you'll want to make sure you integrate that with your VMS. I think now we're ready for our third poll question.
Okay, let me get that set. Okay, so our third poll question is, which of the following is true about access control systems? And you've got system design and complexity requires a pro install technician, or building code should be reviewed to verify the install plan, or access control features need to be controlled in VMS software, or all of the above. And again, we'll give you just a few minutes here to make your selections.
Access control systems can come in different capabilities as well. They come in sometimes in basic formats and also in enterprise level systems. So there's a lot of differences between the various different types of access control systems out there.
Okay, Keith, the results are in, and again, 100% selected all of the above.
I should have made the poll questions harder. But we do have a smart crowd today. Let's take a look at access control. This will fall under security integration for us. Access control is are devices that can help monitor activity and flow around a building. Access control is most common at entrances and exits. Scheduled access is common with main lobby doors unlocked during normal business hours. After hours access is available in most common access control situations. Specific personnel may be authorized for access after hours while other employees are blocked from access. It can be, the access control system can be managed by administrators in the software configuration. They can manage users and schedules in there. The additional layer of access may be added between the lobby and the building interior. Adding locks with access control can help manage people's entry into secure areas. Don't forget about your side and back entrances. They may be less used by employees and guests, but they're securing those areas is still a concern. Most of the time, access control isn't required for hallways. However, if you have high priority targets that open to hallways, you may want to secure those areas with an access control lock. An example would be an MDF or IDF room for network equipment. Offices with high priority targets should be blocked from general access. Locking those with access control technology and software, the software should be able to keep logs for you of who accesses certain areas. Now, your parking lot scenario utilizes security gates to sensitive sites, and they're a good access control technique for parking lots. When you pair those with cameras, you can capture valuable evidence at the security gate choke point. When a fence is not a technology, it's still a form of access control. It can help guide and direct traffic towards your access gates. Access control technology at gates can be added if you determine it necessary. Warehouses are often locked as a loss prevention measure. Using access control to keep unauthorized personnel out is a common practice. And when incidents of theft occur, reports can be run to see who had access when the event is suspected. Access control systems should be a zero downtime system. Doors must always function as expected. You can't afford to design a system that doesn't meet local fire codes or fails in crucial moments. You'll want to clarify which elements of your system should be fail-safe or fail-secure, and this should be stated in your building code. When power fails, you have a fail-safe situation when the electronic locking device is released and the door is unlocked. When power fails, you have a fail-secure situation when the electronic locking device is secured or locked. And these terms always apply to entry control only. Manual egress or exit should be allowed at all times. In an enterprise-level system, door controllers are designed to operate independently even when the network communication is down. Providing backup power for the controllers is essential to make sure the devices continue to receive power if the electricity goes out. Access control systems likely require proprietary equipment at the door, and that functions with the head-end panel or server. The door controller has one function here, and that's bridge the gap between the door hardware and the access control software. Access control hardware usually involves door hardware such as electric strikes or mag locks. You want to make sure you assess which type will be needed. This is not a one-size-fits-all scenario. Choosing the right lock can be complex, and you don't want to tackle that as an amateur. Electric strikes, in our example on screen here is on the lower left. They work on mechanical door locks for securing the door, allowing the locking hardware to remain locked and still gain access through the opening. Strikes can be configured for a fail-safe or a fail-secure mode. However, door hardware must accommodate free egress in an emergency. Two common types of strike are the mortise strike, which requires a cutout in the door frame, and the surface strike, which mounts on the inside surface of the door. When exterior strikes are exposed, make sure you install a latch protector to prevent outside tampering. On modern traffic single-leaf interior doors, electric strikes are most commonly used. These devices are a good selection for security office doors, computer rooms, and storage closets. The mag lock on our picture there on the lower right mounts to the surface of the door and the frame. It provides a strong magnetic bond holding the door secure, and you want to make sure you're providing enough power for the lock to operate and fuse them independently of the surveillance system. Supplying backup power to mag locks is very uncommon as they are designed to fail safe. There are design considerations for in-swinging doors, out-swinging doors, and double door units. Each type may require a different mag lock style. High traffic, single, or double leaf exterior openings typically use mag locks. Main entry openings are secured with mag locks. These devices are very strong and have a low operation cost, requiring minimal maintenance. The higher cost and less discrete mounting options limit these locks for general application. Wireless locks do not require a cable run to the controller. They send a radio transmission to the controller to communicate their data. You want to make sure you test your wireless transmission, test the connectivity there to make sure it's going to work. Maintenance plans involve changing the batteries, and Wi-Fi locks are similar. However, they connect to the network via Wi-Fi signal instead of via a radio transmission signal. Other types of locks include the electronic lock set. That's an integrated hardware assembly containing all components required to be a fully functional, self-contained device securing the door. It includes everything from the card reader to a power pack. It may have some provision for wireless networking. Those lock sets are more expensive, but they're the best answer when quick integration is required. An electronic bolt is a different style of lock. It features a solenoid-driven hardened steel bolt. It's a very strong type of lock that may be placed where high security is desired, but the mag lock is impossible to mount. Exit mechanisms like motion sensors, crash bars, or exit buttons should be part of your design plan. Exit devices are required in the majority of non-residential properties. RTE devices may be manual or automatic. A PIR device is a motion sensor that releases the door automatically as people approach. An RTE push button requires a person to manually release the door by pushing a button. And a crash bar can be placed on a door that'll release the lock automatically when the crash bar is pushed. A card reader's output needs to be compatible with the door controller. Understanding mounting surface and infrastructure will affect which type of card reader you'll choose. In other words, a wall mount card reader may not work on a door mullion or a security gate bollard. When you're talking about credentials, there are several different types. Standard prox credentials require the holder to get the card within close proximity. Smart cards add extra data onto the card. They have an onboard circuit chip that offers higher encryption, storage, rewriting capabilities. That type could be used as a payment card. An older style barcode or magstripe credential is becoming obsolete as FIPS standards become more common. Those are susceptible to degousing and scratches that impact the reliability. And we've all been hearing about gesture-sensitive credentials in proc-style credentials. They're more secure, and they don't activate the proc credentials signal until the card is moved in a specific pattern. A similar type of technology is also being incorporated into cell phones to allow cell phones to be used as credentials. Access control management software has 4 functions. It covers a live view and displays the current state of the system. Door management allows users to configure and schedule each door depending on the user credential. Cardholder management allows admins to configure access groups and privileges. And reporting gives a forensic view of log details. Video analytics is a system that provides advanced solution, typically through third-party software, though sometimes it's embedded in enterprise VMSs. It performs intelligent video analysis and helps automate video monitoring, automatically tracking and identifying objects, analyzing motion, and extracting video intelligence. Your features could include intrusion detection, automated counting, camera tampering, object left behind, asset protection, loitering detection, slip and fall detection, and more. And you can use some video analytics on existing cameras. Typically, analog cameras would be connected to a video encoder that are equipped with analytics. And camera positioning is going to be important here. So you can't just assume that it's going to work in any camera position. Mounting heights are important, as are exposure to sunlight and minimizing angles. Video management systems may or may not have built-in analytics. Make sure the features you require are integrated into the software. False alerts are a well-known problem, and they undermine the confidence of the video analytics system. You need to understand on the front end, false alerts could potentially be high, and make sure you communicate your expectation with your integrator. Video analytics systems can actually miss events if the conditions are not ideal, although they can certainly help you much better in terms of a comparison to motion video. Enterprise systems, if you have more than a few cameras, then you need a tight integration between your access control system, video management system, and video analytics. Without tight integration, monitoring becomes difficult. Most video analytic users do in-house monitoring for their alerts. They may do that through text messages to a staff member on a small system. A security operator may monitor systems via software on a mid-sized system, and then self-monitoring at an internal monitoring station on a large system is typically ideal. Let's take a look at some technology advances. Leveraging drones for video surveillance is no longer outside the realm of possibility. Advances in electronics, batteries, and wireless technologies are making this possible. Drones are increasing their weight capacity. Camera manufacturers are making cameras higher quality in smaller, lighter, and self-supporting formats. Wireless technology linking the camera can now transmit full HD video with zero latency. I've even seen a company that tethers a cable via a thin but very strong microfilament. When you're looking at remote sites, there's a need for turnkey solutions or customized options for deploying security systems at remote sites and perimeter applications. Solutions that are perfect for remote locations with no infrastructure can be developed to meet specific needs. You may consider this for such sites as oil and gas locations, rural equipment yards, water treatment plants, construction sites, and even parking lots. You can have equipment designed in solutions that are self-supporting. They could be equipped with solar panels supporting battery operation. Crucial equipment, weatherproofed in a NEMA enclosure, could be important. You may even transmit your video wirelessly via an LTE modem. And cloud storage has also been a big advance as of late. I'm not a fan of cloud storage for enterprise solutions. Some people might disagree with me, but there's some good reasons why is video data transfer upload requires high bandwidth to be able to succeed. If you want to watch or download the video that's been stored, then you have to pull it back from the cloud. And the cloud service may not be able to push the video out fast enough. To view the data, the storage data that's stored, the cloud service may have to do something to the file to compress its size or quality in order to get it out to you in a time-sensitive manner. Also, your bandwidth costs can become economically unfavorable. Moving video can be very data-intensive. Oftentimes, you might be stuck paying a monthly fee for storage rather than a one-time cost for local or central storage. And you always have to be concerned about security. Agencies with sensitive data should be concerned about cloud storage for reasons of HIPAA violations or FERPA violations. Is your info secure? Encryption is broken by hackers all the time. And you want to make sure your data is stored in a geographically close proximity. Getting the data pulled from a geodistant location will increase latency and return of the video that you're requesting. Now, we want to make sure we don't overlook people. Technology without people is useless, and people without technology are ineffective. With any technology, the people, users, and administrators need to become part of the equation. Training is valuable and shouldn't be wasted or watered down. Your manufacturers must train the integrators to a degree that they can become trainers themselves. Integrators have to make a commitment to get their employees trained on technology. Integrators then have to turn around and train the stakeholders, the end users and administrators. And for training to be effective, users and administrators need to understand the system thoroughly. Give practical exercises, and using a hands-on approach is a good way to do that. Providing a resource for online training is also very helpful. The users and administrators can then access resources later for refresher courses. Repeated use is also helpful. As the users and administrators actually use the system, then they need to be able to ask questions and get answers for the training to be effective. Administrators that become system trainers could provide regular assignments to help the users become familiar with the software. These could test the effectiveness of a tool and help administrators understand the ability of each end user and remind users about the features and tools they haven't used recently. And then finally, let's take a look at what happens after the project. When new security technology is introduced, it's important to consider the future of your investment. Part of getting the most life expectancy out of your equipment is proper care. This breaks down into 4 areas: customer support, service, maintenance, and warranties, both standard and extended. Now, your contract is going to be the deal breaker here. If it doesn't say it in the contract, then the manufacturer or vendor doesn't have to honor your request. Make sure you read your contracts, understand how your system will be cared for during the contract period. Some companies charge for customer support, some include it for free. Make sure you're clear on what is included and what period of time customer support services are valid. That's typically offered as phone support. Your days and hours may vary. 24/7 customer support may not be available. You want to plan for customer support during business hours unless your contract offers a different solution. In the service contract, that is going to cover your break and fix response. This could be on-site or off-site repairs for equipment. Clearly define your required response time for fixes. Next business day is common. Times may vary, such as during the next scheduled preventive maintenance visit or a next business day. Variations can be great. 24/7 response could be expensive, but it may be available. Your service contract usually covers your system upgrades. And system upgrades don't automatically happen. Discussions need to happen on that. Some customers follow the "if it ain't broke, don't fix it" method of system upgrade. Added cameras and licenses, network storage, and equipment, those could be negotiated in a service contract. Your maintenance contract, that covers different work than what's lined out in customer support or service. That'll cover cleaning on a scheduled visit, camera focusing and field of view checks. Camera relocation is typically outside of the maintenance scope and may require a paid service call. Camera firmware updates are a matter of preference. Servers and workstation checks can occur on a scheduled visit. That involves physical maintenance, opening the case, blowing out dust, checking cables, and power supply connections. Your operating system and software maintenance should include checking for unexpected errors. Your software log files need to be reviewed, and customers should be notified if there's any indications of poor health. Software parameters for retention time and motion recording can affect your video storage. They need to be checked. Any wireless equipment should be checked on a regular basis. Now, your warranties, both standard and extended, are going to cover hardware, and they should be defined in the contract. Your warranty covers the equipment itself. The service contract will cover the labor needed for the repair. Your extended warranties may be available as an option, and warranties for all equipment may not be the same. For example, your video server warranty may be different from the warranty on your network switch. So you'll want to make sure you're reading your contract and reading those service agreements to make sure you understand what's covered in given scenarios. That wraps up our formal presentation. We've got some time for a few questions.
Okay, let me just gather those up for us, Keith. Just be a few minutes. Okay, looks like we've got, there's a good question that came in for you, Keith. They want to know, how much storage do you need for a video surveillance solution?
Well, advances in hard drive size makes large capacity storage a little bit more realistic. When hard drive manufacturers have recently jumped up to 6 terabyte hard drives, they're optimized, and those hard drives are optimized for video surveillance. When you're calculating storage, many variables come into play. Some are obvious and some are less obvious. You might use a storage calculator. Those are easy to find on the internet, but and they would obviously cover frame rate, resolution, and maybe which codec you're using, such as H.264 or MJPEG or MPEG-4. Those are usually included in storage calculations. However, less obvious factors that need to be included are quality settings, scene complexity, codec implementation, lighting levels, motion detection algorithms. All of that comes into play. So understanding your storage needs may be more complex than just running a quick calculation on it. You might need some assistance from your security integrator to run a valid storage capacity check.
Lots to consider there, Keith. Thank you. We've got time for a few more questions here. So let me just go through these here. Oh, I like this one. You had touched on health monitoring, remote monitoring, a couple terms you used. So what's the difference between health monitoring and remote monitoring?
Well, health monitoring is an enterprise software function that generates a report from your system, and it's taking a look at your equipment, such as servers and cameras, and the overall diagnostic health of your system. Remote monitoring is a service that's offered by some companies that keep an eye on your activity. It could be monitoring the diagnostic reports of the equipment that's coming from a health monitor report, or it could be monitoring camera live activity for problems.
Okay. Okay, another question. In enterprise software, how do the utilities report the information?
That could depend on services that are available. Some companies provide a remote health monitoring service for a fee, and that's typically generated for your, from your system, but they may be able to keep an eye on that remotely for you. Technicians or customer support staff will remotely monitor those reports generated by the enterprise software and alert personnel within the enterprise of the problems, and they'll advise for next steps, a timeline for repair, and also progress of the solution, as it progresses. Some companies prefer to self-monitor and set up a schedule for running health reports or for cameras and servers on their own. You could also use a feature in some VMS systems called workflow management, and this offers in enterprise software, workflow management can help you set up triggered events. In other words, notifications in predetermined circumstances, such as a camera down or something like that. And that would tell the system what to do should an event occur. So camera goes down, it can set up and send a notification out to the appropriate people, or mark the information within the system, assign it to a certain person. There's lots of different things that could be done. Your opportunities are endless there when it comes to workflow management.
Okay, Keith, I think we've got time for one more question, and we'll wrap up so we can finish on time here. See, we've got about 4 minutes left. So that question is, how can you find out what cameras and third-party systems are supported by the enterprise software?
So often the easiest method is to ask your sales rep or your technician or even customer support. They can typically point you to that very easily. However, you can also, usually manufacturers will have that information available in the website under their support section. You can find it sometimes in your technical documents. In the example of Prospective VMS, we track that information in the administration menu of our software. So it's very easy to access and find out what systems are tracked there and what systems are supported. So if you want to add, say for example, a specific access camera, then you can go into the menu and pull up that information, and it'll be detailed right there in your software.
Okay, thank you, Keith, and thank the attendees for joining us today. Keith will post up both mine and his contact information for future follow-up should you have any questions. There it is. So my name's David. You've got my cell number and email there, and then Keith's contact information as well. As we said previously, we've got a short survey that we'll ask you to complete to help us out with future events, and then we will follow up with the notes from this presentation, the questions and answers as well. So once again, thank you for joining us today.